Now I am going to explain about azeotropic mixture. Azeotropic mixture. What are azeotropic mixture? Azeotropic mixture means mixture of binary liquids which have same composition in liquid state as well as in gaseous state, vapor state, and boils at constant temperature. Mixture of binary liquids which have same composition in liquid and vapor state and boils at constant temperature. Boils at constant temperature. Azeotropic mixture means mixture of binary liquids which have same composition in liquid and vapor state and boils at constant temperature are considered to be azeotropic mixture. Example for azeotropic mixture, so ethanol, that is 95% plus water, that is 5% by volume. Another example, mixture of nitric acid HNO3 and water, that is 68% of nitric acid and 32% of water by mass. So now to understand this concept, I'll explain in different way. So listen carefully, understand the concept. For example, take two liquids in a closed beaker. So I'm going to take two liquids in a closed beaker. Okay. So in a closed beaker, I'm going to take two liquids. One is A, another one is B. So consider A is 2%, A is 5% and B is 95% in liquid state. When AB solution, when both the liquids A and B both will undergo vaporization, so in vapor state also, so take a percentage of A and B, percentage of vapors of A and B. So in vapor state also we will get 5% of A and 95% of B. In liquid state, percentage of A is 5, B is 95. In vapor state also, percentage of A is 5%, B is 95%. So and individually A and B has different boiling points. A and B have different boiling points. When you take these two in a fixed ratio, at that time the boiling point of those two liquids is constant. At a particular temperature, at one temperature, those two will vaporize. I hope you understood this video. And another, by taking chemicals, I'll give example for this. By taking chemicals, and I'll explain the concept. Take example, mixture of ethanol and water. So ethanol is 95%, water is 5%, that is by volume. Boiling point of ethanol is 78.5 degrees Celsius and boiling point of water is 100 degrees Celsius. Individually, ethanol has 78.5 degrees Celsius and water has 100 degrees Celsius temperature. Boiling point. So when you take these two liquids in 95:5 ratio, then boiling point of the mixture, boiling point of azeotrope, boiling point of azeotrope is 78 degrees Celsius, 78.2 degrees Celsius. Now, in this ratio, water and ethanol, those two will boil at, vaporize at 78.2 degrees Celsius. Mixture of binary liquids which have same composition in liquid state and vapor state and boils at a constant temperature called azeotropic mixture. Now, azeotropic mixtures are classified into two types. Azeotropic mixtures are classified into two types. One is minimum boiling azeotrope. Minimum boiling, minimum boiling azeotrope, and another one is, second one is maximum boiling azeotrope. Maximum boiling azeotrope. So azeotropic mixtures are classified into two types. One is minimum boiling azeotrope, another one is maximum boiling azeotrope. Minimum boiling azeotrope means the mixture which shows large positive deviation, from Raoult's law. Large positive deviation from Raoult's law. So maximum boiling azeotrope means which shows large negative deviation, from Raoult's law. Large negative deviation from Raoult's law. And second one, boiling point of azeotrope. Boiling point of azeotrope lesser than boiling point of individual liquids. Here, second point, boiling point of mixture or azeotrope. Boiling point of azeotrope is greater than individual liquids A and B. Here also A and B. And third point, total pressure is greater than sum of partial pressure of individual liquids. For this, total pressure is lesser than sum of partial pressure of individual liquids. Next example for this, positive minimum boiling azeotrope, mixture of ethanol and water. Here ethanol is 95%, water is 5%. Maximum boiling azeotrope, example HNO3 and water. HNO3 is 68%, water is 32%. Understood? So what are the examples I given? Ethanol and water, and here HNO3 and water. Once again I will repeat the point. Large positive deviation from Raoult's law. Maximum boiling azeotrope means large negative deviation from Raoult's law. Boiling point of azeotrope lesser than boiling point of individual liquids A and B. That's why it is minimum boiling azeotrope. Boiling point of azeotrope is greater than individual liquids A and B. That's why maximum boiling azeotrope. Total pressure is greater than sum of E and B. Here total pressure lesser than A and B. That's why it is negative deviation. Here total pressure greater. That's why positive deviation. Examples are given. So once I'll explain by taking examples. So when you take example for minimum boiling azeotrope, ethanol and water. So ethanol is 95%, water is 5%. Boiling point of ethanol is 78.5 degrees Celsius, water is 100 degrees Celsius. So azeotrope, boiling point of azeotrope is 78.2 degrees Celsius. See here, boiling point of azeotrope is lesser than boiling point of individual liquid. That's why it is minimum boiling azeotrope. Boiling point decreases when you take those two in this ratio. Here, example for maximum HNO3 and water. HNO3 is 68%, water is 32%. So boiling point of HNO3 is 86 degrees Celsius, water is 100 degrees Celsius. Boiling point of individual liquids. So when you take in this ratio, then azeotrope, they behave like a azeotropic mixture. Boiling point of azeotrope is 120.5 degrees Celsius. See here, boiling point of azeotrope 120.5 is greater than individual liquids. I hope you understood this explanation of azeotropic mixture. Next one, colligative properties.